Welcome back to the channel. We continue to talk about inverters. We emphasize that the primary objective of an inverter is to convert the DC power to AC power so that we can use the loads. However, we have to also accept and classify that with inverters, there has been development. For an example, a lot of years ago, we just have a typical inverter. We have a charge controller, we have panels, we have a battery, and then we have got AC output. Today, we have got inverters, which can be called as hybrid inverters, which also encompass the functionality of inbuilt charge controllers. So with these new inverters, which are hybrid, what it means is that someone no longer need an external charge controller. So if you don't need an external charge controller, the balance of power now just becomes the solar panels, the inverter, the battery, and then we have got an output. But if we have got the traditional inverter, we have got the solar panels, external charge controller, inverter coupled to the batteries, and then an output. So what we have is the charge controller and the inverter connected in parallel to the battery so that it can receive the charge from the solar panels, and it can also give an output through the inverter. So these inbuilt charge controllers can either be pulse-width modulation charge control, or it can also be maximum power point tracking, which is popularly known as MPPT. So these are the two types of charge controllers that you can have with the hybrid inverters. Then another additional feature is that if we go to the traditional system where we have got an external charge controller and an inverter, these types of inverters can also be classified into two. There are those that would accept an input from utility. If we are talking of in Zambia, we say it's ZESCO. If we talk of South Africa, then we are talking about power from ESCOM. So this is one aspect that can be taken into account. That is for the traditional inverters. And also on the hybrid inverters, you can also have an input, which is AC, and also an output. So from the primary function of a solar PV to provide power in off-grid mode where you don't have utility, the coming in of the hybrid inverters means that the functionality of the systems go a further up. You can either have an entire system on solar and then the utility is a backup, or you can have the system on utility via the inverter and have the solar system as backup. So you hold the flexibility that is there that can give you. So if you are going to purchase an inverter, so you must actually state what is the functions that it should be able to give you. If it's just typical DC to AC, or it should also add the other functionalities like bypass, either in backup mode, or it can actually be the main system and then you have the utility that is a backup. So this is some of the information that you have to consider. If you are going to go for a system, are you going to go for a conventional inverter, or you are going to go for an hybrid inverter? One thing that is universal, one thing that is known, is the traditional inverters will be cheaper than the hybrid inverters. Thank you very much. and see you in the next video.